All right, let's jump right in. We're looking at a pretty bold forecast, one that claims it can solve one of the single biggest puzzles in modern physics.
So here's a huge question that keeps physicists up at night. Why is our universe so, well, perfect? It turns out one of the fundamental forces of nature is way more orderly than our best theories say it has any right to be.
This puzzle has a name, the strong CP problem, but honestly, it's easier to just call it the too perfect problem. You see, the math, all our best models, predicts that the strong force, the stuff holding the core of atoms together, should be a little bit lopsided, just a tiny bit asymmetrical. But when we actually measure it, it's perfect. And I mean perfect to 1 part in 10 billion. That's like flipping a coin 1 billion times and having it land perfectly on its edge every single time. Clearly, something is going on here.
So what if all that perfection isn't just a cosmic accident? What if the universe isn't just lucky, but is actually being fine-tuned by some kind of universal pattern? And that brings us to the proposed solution. It's a theory called Triune Harmonic Dynamics, or THD for short. It was developed by the researcher, inventor, and author Kevin L. Brown. At its very heart, the idea is surprisingly simple. THD suggests that basically all change, everything that happens in the universe, follows this basic 3-step rhythm. First, you get emergence. That's the birth of something new. Then comes contrast, where you have opposing forces creating tension. And finally, integration, where all that tension resolves into a new, more complex, higher state of order.
And this isn't just a concept. It's all described by a single harmonic equation. This is the engine behind that 3-step rhythm. It generates what the theory calls a 3-6-9 pattern, which is proposed to be the universal blueprint for how everything in nature transforms. Okay, so we have this idea of a universal pattern, but how in the world does that connect back to our too perfect problem with the strong force?
Well, here's how the universe supposedly stays so perfectly in tune. The theory proposes a specific mechanism for it, an invisible scaffolding called the Axion field. You can think of it like the universe's own auto-tune system, or maybe a cosmic reset button that's constantly on, correcting any errors in the strong force and pulling any little imbalance right back down to zero. And this is where it gets really cool, because it ties 3 of the biggest ideas in physics together. First, you've got the too perfect problem. That's the why. Second, you have the Axion field. That's the proposed how, the invisible mechanism keeping everything in line. And third, it even connects to the huge mystery of dark matter, suggesting that these axions, well, they are the mysterious stuff holding our entire galaxy together.
Now, what makes this whole thing different from just a neat idea is that it doesn't just try to explain the past. It makes a very specific, time-stamped prediction, one that we can actually go out and test, and we can do it very, very soon.
So, the forecast lays out this very clear timeline. Right now it says we're in the seeing phase. Mainstream physics knows there's a problem, a puzzle to be solved, but the crucial part is the testing phase, which is predicted for late 2026. After that comes the talking phase, where the discovery gets figured out and accepted.
And we're not talking sometime soon. This is incredibly specific. The prediction points to a primary window between October 12th and December 5th, 2026. And during that time, it forecasts that we should expect a major announcement from a top dark matter lab, a place like ADMX, about a strange, non-random signal that our current rulebook for physics just can't explain. And this is the pivot, the whole point. This predicted signal wouldn't just be some random blip on a screen. It would be the very first physical proof of the theory's core mathematical pattern, what it calls the harmonic constant, finally showing up in a real-world lab. Now, this next part is absolutely crucial for any real scientific claim. For it to be taken seriously, it has to be testable. And more importantly, there have to be clear, unambiguous ways to prove it's wrong. That's called falsifiability. So, the theory puts its money where its mouth is. It lays out 3 clear conditions that would prove it's totally wrong. First, if our detectors show that the force is actually random after all. Second, if a physicist can mathematically prove the core theory is impossible and claims a standing $10,000 bounty. Or third, if we find out by 2027 that dark matter is actually some other kind of particle that has nothing to do with axions. So let's boil it all down to one single massive prediction. The entire forecast hangs on this. The idea that the strong CP problem will finally be solved when we discover a specific harmonic beat pattern in the Axion field, and that this will happen by the end of 2026.
And the theory leaves us with this really poetic idea. The universe was never silent. Its rhythm has always been there, waiting to be heard and solved. It suggests that all the patterns we see aren't just random noise, but a deep, structured rhythm we're just now learning to listen to.
Which brings us to the big, testable question we'll all be watching for over the next couple of years. In 2026, will physics finally hear the beat?